Another protocol at the application layer is the file transfer protocol. This is not as popular as the web or the email, but still it finds use. So this protocol is defined by RFC 959, and as the name of the protocol suggests, it helps transfer files from one host to another. Like email HTTP, this is also based on client-server architecture. This protocol supports anonymous downloads. It also supports clear text sign-in before you can download. So this clear text sign-in is not very secure, so later it has been upgraded to support security via SSL TLS, in which case FTP is called FTPS. Probably what you are familiar with is SCP or SFTP. This FTPS is not the same as these protocols. This is very different. Since security is not the focus of this course, we will deal with the plain file transfer protocol. Like you have web browsers, mail readers, FTP also has GUI based clients. You can also do this through command line. Even the web browsers, if you specify FTP:// will let you download files from a given server through the FTP protocol. Again, just like HTTP email, this also employs TCP, and the port on which the server listens is 21. But unlike email and web, something that is unique about this protocol is that it has two separate channels. One is a control channel, another is a data channel. This control channel is used for authorization, browsing the directory listings, and this channel is kept open during a session. But the actual transfer of the data is done via a data channel, and this is closed after each such transfer. I think a demo will make this clear, which is coming up later. And unlike HTTP, which does not maintain state within a session, FTP on the other hand maintains states throughout a session. For example, it keeps track of where exactly a user is currently in the entire directory tree. So for example, if he changes the directory, it knows to display the files that are present in the current directory. So this is also ASCII based, where certain commands are sent over the control channel. These are examples of some of the commands: the user specifying username, pass for specifying the password, list returns the list of files in the current directory. If you want to retrieve a file, you'll use this command, and if you want to store a file on the remote host, you'll use this command. And just like other protocols we have seen so far, there are status codes and phrases, and here are a sample set. For example, sample code 125 states that the data connection is open and the transfer is starting. Sample code 220 states the service is ready for the new user. 331 states the username is okay, I need password, so on. I will let you browse this in leisure. In fact, there are more if you are interested up on the web. FTP supports two modes of operation. One is the active mode and another is the passive mode. Let's look at the active mode first. Remember, I mentioned earlier that FTP has a control channel and a data channel. Basically, this is one TCP connection and this is another TCP connection. To begin with, the client will establish the control channel. So for this case, the client chose, let's say, port 5000, and it is going to contact the server on the designated port 21. And once this TCP connection is established, it could send some control commands, like it can tell who the user is, what the password is, so on. And let's say the client wants to know what are the files that are there in the main directory at the server, for which it wants to use the list command. But the client knows that when it types list, the server will have to send the directory listing, and this directory listing is not sent on this control channel. It needs a separate data channel for this. So before you can even do this list, you have to specify to the server information such that the data channel can be established. So for this, what do you need to supply to the server? Basically, the port on which you are ready to receive the data. So thereby the client will designate one such port and have a process that is listening on that port for that particular data and send this information via the port command, where it will specify the port on which it is ready to receive data. Now the server, when it receives this, it is going to acknowledge it, through one of those status codes, and then it is going to establish another TCP connection. Note that it is now using a different port number at the source, and the destination for this particular TCP connection will be the port that the client has specified via this port command. And once this TCP connection is established, the server is going to pass on the directory listing on this particular channel. So this is the active mode. But there is a problem with this active mode in certain settings. So passive mode tries to address that. So let's look at passive mode. So in passive mode, this is what happens. Again, originally the client is going to contact the server on port 21. It will send that user, pass, so on. But when it wants the directory listing, instead of sending the port information, it is going to say passive, PASV command. As a consequence of receiving this passive command, the server is going to say OK and pass on a port information corresponding to some other port that on which the server is going to listen. Now, once the client receives this port information of the server, the client is then going to establish a TCP connection to the server on this particular port, and this becomes the data channel. Notice that even though the client opened the TCP connection, the actual data flow, that is the directory listing, is coming from the server to the client. And that's fine because the TCP is a bidirectional connection. That is, the same connection can be used to transfer data in either direction. Now, why do you think this passive mode arose? In other words, why can't we just manage with active mode? In what settings will active mode not work, thereby requiring passive mode? Well, if you have firewalls or NAT where incoming connections from outside are blocked or can't get in, then you need passive mode. So FTP can also be demonstrated via telnet. We will look at it. So between the active mode and the passive mode, without having to write any code, which mode do you think I can demonstrate? Passive mode, right? Because in active mode, I basically need to write some code that will listen on this particular port to process the connection that is coming from the server. Whereas in passive mode, since I am establishing the data connection myself, I can just do another telnet. Anyways, here is the demo. So here is a demo of FTP. I have opened two terminals, one to support the control connection and another to support the data connection. First, I'm going to establish the control connection. So the FTP server in this case is the ftp.iitb.ac.in, and I'm specifying the port as 21. So when I type this in, I'm basically establishing a TCP connection to this particular FTP server as destination port of 21. So when I type enter, I'm got connected to it, and you can see this 220 status code along with a welcome message. Now I need to type my username. It's asking for password. I need to type a password. By the way, any password will work. It says login is successful. Now I want to get the directory listing. But before I can even type the list, I need to establish the data connection, for which I need to specify to the other end that this is going to be a passive connection. So I'm typing this. So it got back with an IP address which is saying connect to 10.200.15.2, and it gave me two other numbers which indicate the port. So how does one derive this port information from these numbers? Basically it is 101 times 256 and then you have to add this 146 to it. So that is the port number. So I'm going to telnet to this particular IP address, which by the way is the IP address corresponding to the ftp.iitb.ac.in, and I'm going to specify this particular port number. So it is connected. Now I can specify list, in which case you will see that once I type this, the directory listing has come about on this particular terminal. So it has a whole lot of files, directories rather, which are indicated. Notice that this connection got closed as soon as the data was sent, whereas this connection is still active, and it also told me here comes the directory listing, and it already said that the directory sent OK. Now suppose I want to retrieve this particular file iitb_ca.cer. I can do so with the retr iitb_ca.cer. So again, before I can retrieve this, I will again have to open a TCP connection for the data. So this won't work. So I basically again have to do passive. So it is again going to give me some information. So I have to calculate what this port information is, which is again 256 plus 151. So that is the port information. So again I have to do telnet ftp.itb.ac.in and 27799. So it got connected. Now I can do retrieve iitb_ca.cer. So when I do that, as you can see, it opened a binary mode for data transfer, which is about 798 bytes, and it also said file sent OK, and here you can see the binary data that is being displayed. Once I'm done, I can quit and then it will close the connection. So that's FTP in action. So to summarize, FTP is a very simple protocol that is based on the client-server architecture. Something unique about FTP is that it maintains separate data and control connections, and it also offers two modes of operation, active and passive. And passive helps in NAT and firewall traversers. That's it for now.